Section 4.8 on applications and models. So in this section we're going to be looking at solving triangles and using triangles to solve problems in the real world. So when you are labeling a right triangle, the angles are always capital letters, and across from those angles are the sides with the same letter but in lowercase. And angle C is always going to be your right angle. So when a problem asks us to solve a triangle, they mean for us to find all of the sides and angles using whatever information has been given. So in example 1, we've been given that angle B is 71 degrees and side B is 24. So we're going to use those two pieces of information to solve all the missing sides and angles. So let's start with the angles. So for angle A, well actually I'm going to label from angle B, we're going to label the opposite side, adjacent, and hypotenuse. And we'll come back to those in a second when we work on the sides. Angle C is a right angle. So if I'm going to solve for angle A, I know that angles A and B, the two acute angles in the right triangle, have to add to equal 90 degrees. So we're going to take 90 and subtract angle B, which is 71, and we're going to get 19 degrees for angle A. They gave us angle B was 71, and they gave us angle C was a 90 degree angle. So I have all three angles. Now I'm going to start solving for the sides. So for side A, I only want to use side A and the two pieces of information that was given in the triangle. So that's going to be side A is adjacent, 24 is opposite, and then angle B is 71. So since I have opposite and adjacent, that's going to be tangent. So tangent of 71 is going to equal 24 over A. So I need to get A by itself. So since A is being divided, the opposite is going to be to multiply by A on both sides. So that's going to cancel the A's on the right, and I'll have A times tangent 71 equals 24. I still need A by itself, so since it's being multiplied times tangent 71, then I'm going to divide by tangent 71 on both sides. So the tangent 71s on the left are going to cancel. So A is going to equal 24 divided by tangent 71. So before I type this in my calculator, I need to make sure that I'm in the right mode. All of this section we're going to be in degree mode since we're solving triangles and application problems. So you're going to type 24 divided by tangent 71. And you should get that side A is approximately 8.26. Okay, side B was given, that was 24. So now for side C. So normally when you have two sides of a right triangle and you want to find the third, you would use Pythagorean theorem. But I don't want to use a piece of information that I've already solved for in the problem. I only want to use what's given to me. That way, just in case I happen to mess up on side A, and if I use the wrong answer and plugged it into Pythagorean theorem, then I would definitely get C wrong as well. So go back to the original information as much as possible. So if I'm solving for side C now, I want to use again what was given. So that's angle B and the opposite side 24, and then I'm solving for hypotenuse. So that's opposite over hypotenuse is going to be sine of 71 equals 24 over C. So now we're going to solve for C. So we're going to multiply by C on both sides. So this is going to cancel the C's on the right. So I've got C times sine 71 equals 24. So I'm going to divide by sine 71 on both sides. The signs on the left are going to cancel. So now I have C equals 24 over sine 71. So when I type in 24 divided by sine 71 in my calculator, I'm going to get 25.38. And we're just going to round to about 2 decimal places. You should be pretty close. If maybe you rounded something differently in the problem, you're not going to get too far off from the answer. So in the end, I want 3 angles and 3 sides with the information that's given and whatever I had to solve for. Okay, so number 2 is the same thing. We're going to solve the triangle. This time they give us 2 sides only in this triangle. So I want to solve for side A first. So if I have 2 sides and I'm solving for the third, then I'm going to use Pythagorean theorem. So a squared plus 16 squared equals 52 squared. So that's a squared plus 256 equals 2704. I'm going to subtract 256 on both sides. So a squared is going to equal 2448. Then I'm going to take the square root of both sides. So a is approximately 49.48. Okay, they gave me side B was 16 and side C was 52, so I have all 3 sides. Now I'm going to start with the angles. So for angle A, I'm going to label from angle A opposite, adjacent, and hypotenuse. So I'm not going to use the opposite side since I had to solve for that in the problem. I'm going to use what was given to me, which is adjacent and hypotenuse. So adjacent over hypotenuse is cosine. So that means the cosine of angle A is 16 over 52. We learned earlier in the week that the opposite operation of cosine, what will undo a cosine, is the inverse function. Inverse cosine. If I take the inverse cosine of both sides, then it's going to cancel the cosine on the left. So that means that A equals the inverse cosine of 16 over 52. So in my calculator, I'm going to type second cosine 16 divided by 52. And we will get that A is approximately 72.08. So I know A is 72.08. I know that angles A and B should add to equal 90 degrees. So to get angle B, I'm just going to do 90 minus 72.08. And we get that angle B is 17.92. Now I could have relabeled my triangle from angle B and used opposite over hypotenuse for angle B and used the sine of angle B to solve that way, and it should have gotten the same thing. Okay? So we know also that angle C should be 90 degrees. So in the end, 3 sides and 3 angles should be your answer. Okay, for example 3, it says to find the altitude of the isosceles triangle. So an isosceles triangle is just a triangle with 2 angles that are congruent or 2 sides that are congruent. Okay, so I'm going to label what they gave me. They said that the thetas in these triangles are 52 degrees and B is 4. The altitude of a triangle is a line that connects the base of the triangle to the peak of the triangle at a right angle. So for this triangle, that's going to be right down the middle, and it's going to split the B into 2 equal pieces, so 2 and 2. And I'm going to label my altitude with an H for hypotenuse, not for hypotenuse, for altitude. Usually in geometry books they use H instead of A for altitude. Okay, so now from 52 degrees, the H is the opposite side and 2 is adjacent. I don't need to know the hypotenuse. All we're looking for is the altitude here. So opposite over adjacent is tangent of 52. Will be H over 2. Okay, so then I multiply by 2 on both sides. So 2 times tangent 52 will equal the altitude. So if I type 2 times tangent 52 in my calculator, I get that H is equal to 2.56. Okay, number 4 says the sun is 25 degrees above the horizon. Find the length of a shadow cast by a silo that is 50 feet tall. So we're going to draw a picture. So I've got the ground, a silo, the shadow of the silo. The sun should be on the opposite side of the shadow from the silo. Okay, it said that the angle of the sun is 25 degrees. That's the angle of elevation, so it's from the ground up to the sun. The height of the silo is 50 and the shadow is X. So if I label from 25 degrees, then 50 is the opposite side and X is adjacent. So opposite over adjacent is tangent. So tangent of 25 is equal to 50 over X. So to get X by itself, I'm going to multiply by X on both sides. Then I'm going to take X times tangent 25 equals 50 and divide by tangent 25 on both sides. So then X is going to equal 50 divided by tangent 25. So in my calculator, if I type 50 divided by tangent 25, I get that the shadow of the silo would be about 107.23 feet. Okay, so in example 5, it says that a ladder 20 feet long leans against the side of a house. Find the height from the top of the ladder to the ground if the angle of elevation of the ladder is 80 degrees. So, I've got a ground, I have a house, a ladder leaning against the house that is 20 feet long. The angle of elevation from the ground to the ladder is 80 degrees. We're solving for the height from the top of the ladder down to the ground. So, since X is the opposite side and 20 is the hypotenuse, opposite over hypotenuse is sine. So, sine of 80 degrees equals X over 20. So, I'm going to multiply by 20 on both sides. So, 20 times sine 80 is going to equal X. And so X is approximately 19.7 feet. So that means that the ladder is about 19.7 feet off of the ground. Okay, number 6 says the sonar of a Navy cruiser detects a submarine that is 4,000 feet from the cruiser. The angle between the water line and the submarine is 34 degrees. How deep is the submarine? Okay, so I've got water, and I have a Navy cruiser sitting on top of the water. Then a submarine that is somewhere below the water. The sonar detects the submarine, so that's the straight line distance from the Navy cruiser to the sub. Our angle of depression from the water line down to the submarine is 34 degrees. We're solving for the depth of the sub. Okay, so from 34 degrees, X is opposite and 4,000 is hypotenuse. So opposite over hypotenuse is sine. So sine of 34 is going to equal X over 4,000. So we're going to multiply by 4,000 on both sides. So 4,000 times sine 34. If you type that in your calculator, you're going to get that the depth of the submarine is approximately 2,236.8 feet. Okay, before our last example, we're going to talk about trigonometry and bearings. So in surveying and navigation, directions are generally given in terms of a bearing. A bearing measures the acute angle that a path or line of sight makes with a fixed north-south line. So if you look at this first compass, the angle is coming off of the south pole 35 degrees. So that is south 35 degrees east. South from the south direction towards east 35 degrees. In air navigation, bearings are measured in degrees clockwise from the North Pole. So in this second picture, we see that the angle that is formed is coming from the North Pole around clockwise 225 degrees. So we would just say that that is 225 degrees. So in example 7, it says that a ship is 45 miles east and 30 miles south of port. The captain wants to sail directly to port. What should the bearing be? So if I start from port, and the point is the port, and I go 45 miles east, and then 30 miles south. This is where I land, that bottom point. And the captain wants to go directly back to port. So we're solving for this angle in the triangle. So 45 miles is opposite, 30 miles is adjacent. So opposite over adjacent is tangent. So tangent of our angle is equal to 45 over 30. So again, if I'm solving for an angle, we're going to do the inverse tangent of 45 over 30. So if you type that in the calculator, second tangent 45 over 30, you're going to get 56.3 degrees. And that's this angle. So if we redraw a compass at this point, that is 56.3 degrees off of north in the west direction. So one bearing might be north 56.3 degrees west. Or if you want to do a bearing, a different type of bearing, you go from north around to that angle. So you would do 360 minus 56.3 to give you the bearing in degrees. So this will be a bearing of 303.7 degrees from north. Okay, so your assignment is on page 359. You're doing 2 through 14 evens and then 16 through 28 every other even.